Welcome to Unshielded, the podcast where we explore the cutting edge of blockchain, data protection, and the quest for a more equitable and accessible internet. Today, we're joined by Kevin Millikin, Principal Architect for Midnight at IOG. Kevin is a seasoned expert in software architecture with nearly 20 years' experience designing and implementing programming languages. He's worked on implementations of JavaScript, Dart, and Python, and in this episode, we'll discuss an introduction to Compact, Midnight's programming language for smart contracts, why Midnight needs its own language, simple worked examples of using Compact, and what developers can expect in the future features for Compact. Kevin, welcome to the show. How are you doing today?
Very good, thank you.
Thank you so much for joining us. It's a pleasure to have you here and really excited to get into a little bit more detail around Compact. You've had an impressive career in software engineering, including a long stint working at Google. Kevin, for those who haven't met you, could you share with us a little bit what drew you towards Midnight, blockchain, and what motivates you to work on developer tooling and languages?
Yeah, I've always had a focus as a language designer and language implementer on developer experience. One of the things that I've learned over the course of my career is that languages are adopted for lots of non-technical reasons. And one of those is, do they provide a good developer experience? So I think that's really important. I do not come from a blockchain world. I come from a designing programming languages, implementing programming languages world. I had a stint at DeepMind where I worked on machine learning, building dev tools for the machine learning researchers there. And what drew me to Midnight was that I met with the head of architecture at Midnight and found out about this project. And I just immediately said, that's the kind of thing I need to work on. So we're building a platform, and the platform is what drives the adoption of the language, not the language itself is not the thing. And I really believe in this platform.
Fantastic. Thank you so much, Kevin. And blockchain, does it feel different to work with blockchain compared to working with some of your other work in Web 2 or with AI and LLMs?
It is. I would say that I'm constantly finding that my intuitions are violated about things. The architecture team for Midnight is really strong, and we have a lot of specialists in a lot of different areas. So that's really good, and it lets me focus on just providing a programming language and a developer experience that will serve DApp developers.
Fantastic. Thank you for that, Kevin. As we know, a blockchain ecosystem or a network survives and thrives on the quality, breadth, and diversity of its developer network. And so as a result, the languages and the tooling are critically important. For those who haven't encountered Compact to date, how would you describe it? And what would you say are the key features of Compact that developers should be interested in?
Yeah, so I would describe Compact as a restricted, TypeScript-based, domain-specific language. So handling those in reverse order. It's a domain-specific language. It's not a general-purpose language. It's intended for a specific domain, which is writing smart contracts that run on the Midnight network and that preserve private data, that hide private data from the chain. It is TypeScript-based, and that means a couple of things to me specifically as one of the main designers. Number one, it should be readable to anybody who can read TypeScript. So it shouldn't feel like a new language. And number two, if you're working as a developer in an environment where you're switching between writing some Compact code and writing some TypeScript code, it shouldn't be a jarring experience. It should feel seamless.
Very good. And so the experience for building smart contracts on Midnight, the ability to start programming blockchain-based decentralized applications, this should make it easier, or being based on TypeScript should make it easier for developers maybe who have less experience with blockchain or who come from other industries or other technologies to start playing with decentralized applications. Is that a fair assumption?
Yeah, we want that to be true. It is important to highlight that writing a smart contract is different from other kinds of TypeScript code that you might write. So it's not the case that you're going to come in with no knowledge about how things work in the smart contract world and be able to just hit the ground running. So there is, and the burden is on us to produce good developer documentation that educates our developers about what the things that they need to be thinking about is.
And you mentioned that Compact is based on TypeScript, but more of a reduction than it is the full TypeScript language. I'm interested, and I'm sure many listening would feel the same way. With so many established programming languages in the world today, why does Midnight require its own domain-specific language?
it would necessarily be a different language than any other language. It's restricted for a specific reason. We need to be able to run our contracts on chain, but we also need to be able to construct a zero knowledge proof that we ran them off chain with access to private data. And that restriction really determines what we are allowed to express in the language.
And so you have to take some features away from the TypeScript language you might otherwise use in order to enable that? Or are there specific functions we need to bring in as well?
Yeah, we didn't really look at it as a process of taking features away from TypeScript. We started with nothing, and we looked at it as which features can we add. And as we add features, let's make them work as much like TypeScript as is reasonable.
Understood. And so what's different about programming in Midnight, particularly with its use of zero-knowledge proofs compared to trying to build applications on other systems and languages from your experience so far?
Yeah, there's a really, really big difference that if you're building a decentralized app or so-called DApp for a chain like Cardano or Ethereum, you're used to thinking of two kinds of code. There's code that's run on-chain and there's code that's run off-chain. The on-chain code is your contract, and all of the data that the contract manipulates is public. It's exposed on-chain. It can be seen. So with Midnight, there is another dimension where there is two kinds of data. We have private data and we have public data. And so that dictates that we run the code a little bit differently. And I'll give an example of that a little bit later. What's important to realize is that with Midnight, your code is actually run in a manner of speaking. So run is in air quotes. Your code is run 3 different times. The first time your code is run, it's run locally on the DApp user's machine or their device. It has access to all their private data. The second time it's run is running in a manner of speaking. It's given to a proof server, and the proof server constructs a zero-knowledge proof that the contract ran, and it had some inputs, and it produced some output. But what that zero-knowledge proof proves is that there exists private data that would make that contract run with the observable behavior that we had. It doesn't expose the private data. The third time your contract is run, it's run on chain. So the nodes in the chain are going to actually execute a little byte code that runs the program. And now there's no private data.
Got it. So slightly different from sending a direct call to a server online in the cloud and then receiving information back. Slightly more complex, but with slightly more rich functionality.
Yes. And so one of the things that's important as a constraint on the way we build the system is those 3 different runs of the program have 3 different program representations. When it's running locally, we're just running JavaScript code in your browser. When we're proving it, we have a so-called zero-knowledge circuit that we're proving that the proof server is proving. And when it's run on-chain, we have an on-chain VM that we've built, which is called Impact. And we're running Impact code on-chain.
You mentioned you wanted to get into an example, so let's do that. As the Unshielded community will know by now, this show is all about giving demos and visual examples. So could you take us through a tutorial or maybe a worked example of using Compact so people can see it in action?
Yeah. So in episode 4, Jonathan Sobel walked through how you put together our example bulletin board DApp. And I was going to just use bulletin board as a jumping off point. So if you want to see how it was put together, go back and listen to episode 4, hear Jonathan's explanation. But I'm going to do more of a deeper dive inside what's really happening when you run the bulletin board app. So the first thing I'll show is that this is the code for the bulletin board app, and I've shrunk down all of the circuits except for one. So I'm showing the post circuit on screen here. Starts on line 19 on screen. And it says export circuit post. So a circuit is what we call a part of the contract that we can prove in our zero knowledge prover. So this is a circuit. Export means that it's actually publicly visible. So this is one of the entry points to the contract where users of the contract will interact with it. If you remember the scenario behind the bulletin board app is there's a bulletin board. You can post a message if there's no message on the board. Only the person who posts a message can take it down. Other people can see it. So the logic behind the post implementation is very simple. We just first say that we assert that the public state on chain is that there's nothing on the board. If that's true, then we do the computation involving our secret. Our private data is our local secret key. So we have what we call a witness that has access to the private data. This contract code is written as if it works with private data, but on-chain it won't. So we see on line 22 that there's a call to a local secret key. That's our private data. We write the public key to the ledger on-chain. We write the message to the ledger. We change the state. Very simple. This is the code. Now, what I'm going to do is I'm going to run this in my browser. So here's my browser window. I've created a bulletin board. I'm about ready to post a message. And what I want to do is I want to set a breakpoint in the debugger. So I'll stop when a message is posted, and I'll show you what happens. So I'm going to write a short message. I'm going to say the Wisconsin State Fair is coming up. And I'm going to post this. So before I do that, I'll open the Chrome Developer Tools. And I'm going to post this message. Now what's happened is I've hit my breakpoint. It's a function that's called #post_0. That is the implementation of the post circuit that the compact compiler has generated as this JavaScript code. And the interesting thing that we can see here is we can already inspect what's happening. There is something here called the context. And in the context, we can see our private state. This is my secret key. So this JavaScript code has access to my secret key. It's here encoded as an array of 32 bytes. We can also see something that we call partial proof data. At the end of this circuit, we will have built up the full partial proof data, and that's what we will hand off to the prover to prove. So we can see inside the partial proof data, we can see our input. This was my string. This is the ASCII encoding of my message on the bulletin board. So that's the input to this circuit. And we can see something called private transcript outputs. This is the private data that is, again, going to be given to the proof server to prove the transaction. Right now it's empty. Let me step forward in the debugger. I stepped one line forward. I stepped over this string about attempting to post to an occupied board. That was our first assert, if you remember the code. Now this is the line that's going to have access to the private data. If I step over that and I inspect my private transcript outputs, there's one thing there. And what it is this is my secret key again. So my secret key is going to be also given to the proof server when it constructs its proof. The proof server is going to prove that it knows the secret key, but it's not going to reveal what the secret key is. Now I'll continue to step forward until I get out of this function. And now I'm done. And so now we've started to do this transaction. We've run it locally. The next step is that we will send this to the proof server. I'm running my own proof server here. And let me just show you what will get sent to the proof server. That partial proof data that we have here, it has our input, has our output, it has all of our private data that we need to prove. Now here, let me just show you, this is a representation of the same circuit called post that is given to the proof server. It's in a language we call ZKIR, which is a zero knowledge intermediate representation. It's basically a JSON object. We use it to build what we need to construct the proof. And it's really complicated. This is not something that a programmer wants to write. So this is one of the reasons why we have compact. The programmer wants to think about an algorithm, a program, and the compiler will generate this. The programmer doesn't have to generate this. There's no API for the programmer to generate this. We build this automatically. And again, this is the restriction on the language. We have to be able to compile to this language so that we can prove that we ran the computation. And this is just, you're not expected to understand this. You're expected to believe that you don't want to write this by hand. Going back to my app, we can see the final form that the program will take is when it's going to be running on the chain in the impact VM. And that's also visible here. It's what's called the public transcript. And so there's 14 instructions that the impact VM will have to do to run this simple circuit. And the instructions are things, it's a stack machine. So instructions are things like dupe, which duplicates the top of the stack, index, which indexes into the stack, and pop instructions, push instructions. So all of these are instructions, and I can see that it's duplicating the thing that's at index 0 on the stack. and it's indexing it's not cached, it's indexing the thing that's somewhere in the stack. So this is the impact VM code. This was also built up while we ran the circuit locally. So we ran the circuit locally, we built up the proof data that we're going to give to the proof server. We built up the impact VM code. When we submit the transaction to the chain, this is what we'll send, along with a verifier key that we constructed the proof with no leakage of private data.
Fantastic demo. Thank you so much, Kevin. Really clear, and hopefully for those watching in with a JavaScript or TypeScript background, we'll see some familiar procedures, some familiar coding structures. Certainly as you get into the ZKIR, that's more of the zero knowledge technology that, like you said, we're keen to obfuscate with the compiler. We're trying to keep focus on being able to develop in languages and in programming tools that are familiar to those developers out there who are already building other applications at scale. A domain-specific language here, basically, that's relatively simple to get on board with. So thank you so much for giving the introduction and the demonstration. Let's look forward now. So Midnight and Compact are still in their relatively early stages of development, and there's already been some great feedback from the community in terms of new features and enhancements, but what else would you like to see on the roadmap, or what are you planning to focus on in the coming months ahead?
Well, we've said that it's TypeScript-based, and right now, developers who've used it will know that there's some superficial differences from TypeScript. And so one of the very next things we're going to do is we're going to make some syntactic changes. And these will be breaking changes. So people will have to recompile their DApps if they have things that they're working on. You can see that Compact uses square brackets for generic type parameters, and TypeScript uses angle brackets. So that's the kind of superficial difference that we don't really want. A programmer switching back and forth has to keep track of which context they're in and which one they're going to use, and we don't need that at all. So we'll adopt the angle brackets. It's a simple change. Another change that we'll make is that Compact has a notion of null, which isn't the same thing as TypeScript's null value. It's a different concept. So we're not going to call it null anymore. We're going to change the name. The name we'll use is probably default. It's a default value of a given type. It's not a null value. So we're going to make some changes like that, and those should be bring us more into alignment with TypeScript.
For those developers that are using Midnight today and that are already working with Compact, what would you recommend for them in terms of being able to give access to the team to be able to give their feedback?
We have a Discord channel, and there's a dev corner on the Discord channel. So I would suggest that is the easiest way to reach somebody on the team. Our DevRel team is monitoring that constantly, and I'm looking in 3 to 5 times a week just to see what's new there. At this point, we would love feature requests. We'd love to know things that are painful to do. I'm often finding myself missing features of things that I want. Some of these are ones that I know technically we can't actually do in circuit. And some of these are things that we just haven't implemented yet. So it's always worthwhile to bring them up as feature requests with us. Another thing that we're going to work on is there's some programming features that we can provide that don't have any impact on our ability to construct the ZK proof that we need. So an example of a feature like that might be type aliases. Types in Compact can be kind of verbose, and it would be really nice if you had a way to define an alias, a shorter name for a type. We don't have that feature now. That's one that I hope we will add. Another feature that we're working on a lot is the ability to have a DApp use multiple contracts in a specific way. So right now you could have a DApp that interacts with 2 separate contracts. But what we'd like to do is we'd like to actually have a contract that uses as part of its implementation that it interacts with another contract. So an example of that might be, a fairly frequent example we use is like an identity verification or an age verification contract. If we had a contract that could do that, we could build some more complicated contract on top of it, and it could use that as a service in circuit that you could actually prove. So a specific way of combining a pair of contracts to work together, or multiple contracts to work together.
Very good. So lots on the roadmap ahead. Lots still to do.
I want to put one more on the roadmap. So when I joined to work on the language, I rebranded the languages team as languages and developer tools. So one of the things we want to build is better tools for debugging. We want to build better tools for editing programs. So right now there's a VS Code, a Visual Studio extension that does syntax highlighting and a few other things. We'd like to make that into a full-featured language extension that allows navigating, refactoring, all of the things that you'd expect from an IDE.
Very good. Lots for developers to look forward to. And Kevin, clearly you've received a lot of feedback and have some great ideas. So looking forward to seeing those features release in the coming few weeks and months. And I'm assuming that through Discord and through some of the other Midnight channels, the updates will be made available so developers know when they're going to come through?
Yeah, it's actually something that I'm eager that we do a really good job with, is communicating with developers. So when we make a change to the language, whether it's adding a new feature or especially a breaking change, I think it's very important that we reach developers, that we tell them very clearly what change we're making, and explain to them why we're making the change, especially when we're asking them to update their DApps, because they have to feel that there's a reason that we're asking them to do this. The pain of being an early adopter is that sometimes things change underneath you. And so we need to clearly communicate what we're changing and why. Where feasible, we need to explain how to change your programs, or even provide automated tooling that would automatically change your program, for instance.
Very good. And Kevin, as we wrap up our discussion, what advice would you give to developers or organizations looking to innovate in the space of decentralized applications with data protection or using blockchain technology? You've come from a more traditional developer background, and now you find yourself knee-deep or maybe even deeper in blockchain technology and code. What advice would you give to others?
Yeah, I think you have to just try it out. One of the things that surprised me over my career is that we never knew what developers would do with the technologies we were building. I worked on building a fast JavaScript engine, and we didn't actually have any idea at all what creative things people would come up with to do in browser and on the server with JavaScript when they had that technology in their hands. So it's hard to predict where it's going to go. One thing that it took me a little while to realize is that the Midnight Network guarantees some things, but it doesn't guarantee everything. So we have an example of a battleship game, for instance, that you can play on chain. But the DApp, the Battleship DApp, doesn't automatically prevent you from cheating. The DApp developer had to build the DApp to prevent you from cheating. So the network doesn't provide that. So there is something on the DApp developers' plate, which is they have to understand what the network is guaranteeing, and they have to understand what are the privacy characteristics of their DApp.
Very good advice, Kevin, and thank you very much for taking your time today. That's a wrap for today's episode of Unshielded. A huge thank you to Kevin for sharing his insights and expertise on the innovative technology and the foundational programming language behind Midnight that is compact. If you're inspired and want to learn more and start building, be sure to check out Midnight's documentation and resources at docs.midnight.network. And if you've enjoyed this episode, be sure to subscribe, rate, and leave a review on your favorite podcast platform. And don't forget to follow us on social media for the latest updates and more exciting conversations in the world of blockchain and data protection. Unshielded is brought to you by Midnight. To find out more about how the Midnight Network is helping everyone to build a more equitable and accessible internet, visit our website at midnight.network. And remember to search Unshielded on Apple Podcasts, YouTube, Spotify, or wherever you get your podcasts, and be sure to subscribe so you'll never miss an episode.